Have you ever wondered if the massive depth of modern computer vision models is actually necessary, or just a byproduct of how we train them? The paper we are discussing today, Block-Recurrent Dynamics in Vision Transformers, argues that these deep networks are essentially running the same simple program over and over again. Standard vision transformers, or ViTs, have become the gold standard for image tasks, but they function largely as black boxes. Their internal flow is poorly understood, which makes them incredibly difficult to inspect, diagnose, or explain scientifically. To address this opacity, the researchers introduced the Block-Recurrent Hypothesis. They propose that a trained, distinct deep network actually organizes itself into just a few phases, where the computation is recycled and applied repeatedly, rather than requiring unique parameters for every single layer. So how do the authors verify if this hidden structure effectively exists within established models? They start by visualizing the internal similarity of the network, as seen here. This graphic reveals distinct square blocks along the diagonal, proving that groups of consecutive layers are producing highly similar features, effectively doing the same work. Using a max-cut algorithm, they segment the network into phases of high similarity. They then build a surrogate model called RAPTOR, which explicitly uses shared weights, meaning the exact same parameters, to mimic the behavior of these phases repeatedly. This isn't just about matching the final output. The RAPTOR model is trained to reproduce the entire internal thought process of the original teacher model. They use a technique called teacher forcing to ensure the student model stays on the right path during the early stages of learning. The methodology sounds sound, but does this compressed model actually perform as well as the full-sized original? The results are quite staggering. The authors took a standard 12-layer Dyno V2 model and reduced it to just 2 recurrent blocks. Even with this massive simplification, the model recovered 96% of the original's accuracy on ImageNet. They validated this with causal interventions. They found that swapping layers within a block works perfectly fine, but swapping layers between different blocks causes the model to fail, proving that each block represents a distinct, necessary functional phase. This implies that vision transformers act like dynamical systems with self-correcting properties. If you slightly nudge the internal data, the network's natural flow pushes it back toward the correct solution, largely due to a simplicity bias inherent in the training process. To learn more, head to emergentmind.com.